out. Let us continue to the next thing, which is data processing and storage. So basically, data processing is the conversion of data into usable and desired form, then stored physically on a hard disk, which is a local server, and or virtually in the cloud. In the first step of the data processing and storage procedure, the first step is input. You cannot process data that you don't have. Always process the data that you don't possess. So first of all, this is the data collection process. The data collection process is basically the gathering and measuring of information over targeted variables. So the targeted variables are the type of probably I'm doing a research on, I'll use Maggie's example, you're doing a research on income and hometown to see if there's any if they affect each other. So first of all, the targeted variables will be those two: income, hometown. Then gathering and measuring them, making sure it's gathered and measured in the type of measurements you want. For hometown, since it's not it's qualitative, it's kiko sawa. Then for ordinal, for the nominal qualitative, you have had the nominal qualitative in the town. Sorry, I was accepting someone, that's why I'm fumbling. The nominal qualitative is the hometown. Alafu the other measurement, make sure it go in cash form, etc., etc. Then you go to the cleaning part, where it's basically fixing or removing incorrect, corrupted, wrong format, or incomplete data. For example, you sent maybe Google Forms to people, or you're collecting the data yourself, probably with a paper, which I never recommend. I usually like using the softwares, or either the softwares or the applications, because it makes it easier to extract the data, and the data is goes directly to your analysis tool, most probably Excel. But let's say you're collecting data with a paper, or while you're collecting the data on your application, the age of someone, you write 21, then you mistakenly put a W. So during the data cleaning process in your maybe Excel, the age, where the ages are here, you have the age X, age Y, then you have this here. You have to go now and realize that there's an age that is 21W, which will not be able to be calculated, or averages, etc., and come and remove this W to make sure it is 21, and it can be used to calculate the averages. So this is just an example of data cleaning. Or maybe the date format, you put it in a wrong way, and it's reading rather than January 1/2/2022, and you wanted it to be 2/1/2022. You wanted it to be January. You wanted it to be February 1st, not January 2nd. So these types of cleaning, making sure that the wrong formats are removed, you've fixed, you're removing correct values. Probably you're writing a person who has 10,000, who wants 10,000 every month, then you add an extra 0. So you have to come and know how to make sure the data is clean, and it's very clean, so that, because it's garbage in, garbage out. If you put any incorrect value, the information that you'll get will be incorrect. So you have to clean it, fix it, remove incorrect values, corrupt, wrong formats, etc., etc. Then you do the encoding. The encoding process is basically converting the data to a sequence of characters, e.g. zeros and ones. So for example, you have asked on a scale of strongly agree, to agree, moderate, or neutral, then disagree, then strongly disagree. And you have collected this type of data. Now, during the encoding part, you have to give these values, either 0, 1, 2, 3, 4, or 1, 2, 3, 4, 5, according to how you want to encode it, so that you are not dealing with these values in words. You are dealing with these types of sequences or characters to help you do the analysis part. Then once you're coming to convert them later, you convert them to what they actually meant so that you can write your report. So the encoding patterns involves this the encoding part involves these types of just converting the data to a sequence. So it's very uses characters or numbers to do that. Then once you've done that, once you've collected the data, you've cleansed it and you've encoded it, you have to process it. The processing part is basically giving it instructions and transforming it. Where you use algorithms, where you put a set of instructions, categorizing the data, analyzing it, deletion of personal information. If it's data that has personal information, like for the social media companies, there's a deletion process during the analysis part of the very personal information. Or if the data itself has a couple of, for example, projects done by agricultural students in a certain university, and just processing them, giving them instructions. If it's anything that is dealing with weed, put it in weed management. If it's anything that deals with birds or chicken or rearing of ducks, put them in poultry farming, etc., etc. So that once you have an output, you have information which is basically has a more meaning than data in its individual form. Then you go to the storage part. You can store it on a local server or on a cloud-based server. So for the local server, who thinks, just raise your hand if you think you know what the local server is. Sorry. I'll give you 5 seconds to raise your hand. If you don't raise your hand, I will get somebody to answer me that question. What is the difference between a local server and a cloud-based server? What is the difference between a cloud-based server and a local server? 5, 4, 3, 2, 1. Oh, Mitchmash.
I can say a local server is it's a collection of the data local. Let's say a few, not large data, but minimal data for, let's say, a researcher's report or something. That's a local server hosted using something like XAMPP or WAMP. Then cloud is a collection of data that can be partitioned or can majority of in the web, like Facebook has their own.
Okay. Yeah, very good, very good. Funny thing, I've actually written Facebook as one of the cloud-based servers example. You have actually said it too. So thank you very much. Who else thinks they knows the difference between the local server and the cloud-based server? Thank you very much, Mitchmash. 5, 4, 3, 2, 1. Okay. I'll explain the local server and the cloud-based server in a very, very simple way to help you understand what I mean. Let's say, for example, the research, we have done the research from McGee, from the previous example, and we're trying to see if income is affected by the town in which a person lives. We have collected the data, we have put an algorithm to help it understand the information, and then we have extracted the information, and now we want to store it. We can store it, let's say I was doing a research on my computer. I can store that information on my computer. Nowhere else, on the hard disk of my computer. And now that is a cloud-based. That's a local-based server for that research. Your images that are in your phone, the images that are on your phone, Images that are on your phone are on your local server. This is your local server for the images and the videos that you have on your phone. This is a local server for those. If I take a video and put it on this flash disk, this is a USB-C. It's a flash and a Thunderbolt flash, which is the USB-C type. It's a SanDisk. I think it's how many GB? I don't know. 128 GB. So this SanDisk is the local server for the videos that I'll put inside here. And having a local server is very risky because the information that you have on this phone or on this flash disk will disappear with that flash disk or that phone. If it gets damaged, magnetism affects it in any way, or this phone is affected by magnetism or in any way, anything that might affect it, that will be the end of that information. But now to understand the cloud-based server, we can use this example. Let's use electricity. For you to have electricity in your house, you can have two options. Either you generate your own electricity. You either have a windmill, ununue windmill, weke hapo nje ya nyumba. Make sure you live in a very windy area, first of all. Put a windmill, make sure they're rotating the turbines, producing electricity, then storing that electricity inside very large batteries, and the overflow of electricity be used as it's being produced. Anything that after the batteries are full, the extra electricity, you can use it as the wind is there. When it's not there, you use the batteries. Or you can have a geothermal plant of your own, where you make sure you live in a place with a very hot springs. Use the hot springs to rotate turbines to create electricity in your house. Or live in a place where there's a waterfall and use the waterfall as a means of rotating the turbines. Rotate the turbines, put electricity in your house, and you have electricity. That's method number one. Method number two, you can work with KPLC. They go and get electricity from the geothermal farms, and they get electricity from the wind electricity in Ngong area, get the geothermal electricity from them. Then they send electricity to you directly through their wires. Which one is easier, method one or method two? Which one is easier? Which one is an easier method of getting electricity in your house, method one or method two? It's overwhelming. It's overwhelmingly big towards this number two, because who wants to have all that in your house? Now, the wind machine, if you break down, you will be the one who will sort it out. But once the wind machines have a problem in Ngong, you don't care, as long as there's electricity in your house. And that's how a cloud-based server works. They have their storage. For example, Amazon offers a cloud-based storage. They offer cloud-based storage. Google offers cloud-based storage. Once you have a Google account, you're given 15 GB for free. And that's a cloud-based storage. So everywhere you have your phone and you have Google, you can just log in, go to Google Drive, extract a picture. If it's on your laptop, enter Google Drive, extract a picture. If it's your friend's phone, if it's his laptop, wherever you are in the world, as long as you have internet, you have access to those pictures. And that's a cloud-based server. In that, Google themselves have very big spaces and servers and storage space in different parts of the world, from Oregon to North Carolina to Iceland. They have storage areas with millions and millions of terabytes of data space. So what they do, they give you a section of 15 GB from that place, either in Oregon or in North Carolina, and then you access that space through the internet. So basically what happens, Let me just move this. Give me a second. So you have this very big data. Let me just draw something here. You have this very big storage of X TB, millions and millions of TB in a certain area. Then this is the internet. Then this is you with a very small neck, but yeah. So what you do, you have a 15 GB space here, 15 GB. Then through the internet, you connect to this 15 GB and use it. So without the internet, you cannot gain access to this 15 GB. But the 15 GB will always be there for your Google account, Gmail. And that's how it works. And it's very, very advantageous. Why is it advantageous? Because it's accessible from anywhere in the world. It's accessible from any place you are in the world. It's accessible to wherever you are in the world, you can access this database. You can access this data rather than having the information on this flash disk. And if I leave it at home and go to town, I cannot access the pictures in this local server. But since a cloud-based server, I can access it as long as I have internet connected. And that's the difference I was talking about. Rather than having your own infrastructure, rather than having your own electricity infrastructure, you can just connect. Rather than having your own electricity infrastructure, you can just have a KPLC bring the electricity to you. The same applies to this. For example, you can buy 1 terabyte of, or let's say 10 terabytes of data from Google at a certain price. So once you get this 10 terabytes of data, let me just erase this. Once you get this 10 terabytes of data from Google, they give you 10 terabytes from here. Remember, they have millions and millions of terabytes. Once you have these 10 terabytes, you don't have to have 10 terabytes of space on your laptop, or 10 terabytes of space on your phone, or 10 terabytes of space on the gadget that you're using, or a flash that has 10 terabytes. All you have to do is have internet connections, and you can access 10 terabytes of information, which is very, very important. So you can just get 10 terabytes of space as long as you're connected to the internet. And that's the importance of a cloud-based server. And that's why people use cloud-based servers. So for example, Facebook has their own cloud-based server, which you connect through the internet. Probably you have pictures that you were there. Let's say Facebook, I just put Facebook here. B. So Facebook has information that are stored in their server. You as the user connects to Facebook through the internet, and then you can get pictures from 10 years ago. Because they're stored on a cloud-based server with a certain space given to you or given for Facebook. So you can access your friends' pictures from 10 years ago, you can access your own pictures from 10 years ago, etc., etc. Or same as YouTube and etc., etc. So that's the most important thing about a cloud-based server. So that's why people use cloud-based servers, because they always store the information, and you can get as much information as you want, space as you want, without having the necessary infrastructure or the necessary physical space to use. I hope I have made sense. Okay. If if you're together, remember I had a question for you guys, so be ready on the chat section. Be ready on the chat section. What was the assignment I told you to do? What was the name of the documentary? The last person to give me that name, will answer our question. The last person to tell me what documentary you are supposed to watch will answer our question. Last person to answer our question. I think Velma, Emmanuel, and Cynthia. We are waiting to see who will be the last one. Velma, Emmanuel, and Cynthia. Let's see who will be the last one. Velma, Emmanuel, and Cynthia. Okay. Oh, Emmanuel was not there. Emmanuel was not there. And Cynthia has a problem with her internet. So who will answer us? Velma. Since Cynthia was not there in the beginning of the class, she does not know what the question was. And Emmanuel was not in the previous class. And he has answered the previous question. So it's up to you, Velma. Remember the question. Continuous quantitative with ordinal qualitative. Velma, give us a research that can use these two types of data. Give us a research that can use these two types of data. You can just write it on the chat section if you're not comfortable speaking in class. Velma, 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. We'll go to the person who was just before Velma, who was just before Velma, and it was Margaret. Already gave us an example for the other one, so we'll go to the next person, which is Peter. Peter, give us an example. Continuous quantitative with ordinal qualitative. Performance of different genders in class. Very good. Performance can be inaweza kuwa, for example, grade marks in math. Right? Right. So performance can be marks in math, 80%. Then the gender can be male or female. But yeah, that's a very good example. But male and female, does this have a specific order, Peter? Does it have a specific order, male or female? It's like yes or no. Yes or no. gender is not, I don't think gender is ordinal. Gender is not ordinal. Gender is like yes and no. And yes or no question is a nominal data point, which has options. It's like ulizwe, where do you live? Kenya or Uganda? Just because there are options does not mean it's ordinal. Male or female is not ordinal. I don't think it is. I don't know. It's not. It's not, Peter. Very good. But male or female is not ordinal. Think of another example, Peter. Think of another example. Yeah. Emmanuel seconds me. It's male or female is not ordinal. The question, Cynthia, is determine, and wait a minute. Determining temperature of a given place. A given place is not ordinal, it's nominal. And temperature is continuous. So that's good, but still I need something else that is not nominal. It's ordinal. Give me an ordinal. You've given me temperature, which is continuous, but now I want an ordinal data point.
We can have a performance of legislatures or MPs.
Performance of MPs.
Yeah, the performance. We can gauge them according to their years and the work they deliver. So you can have an age group of 40 to 50s and the way they do their work in their constituencies. Can it work?
Okay. We are looking for an ordinal data point. Which will be the ordinal data point? I get the 40 to 50 years, which you will collect basically for age. For age, it will be discrete.
Yeah.
Age is discrete. But once you get the age, you'll convert it to a continuous data point where there'll be age groups, 40 to 50, which is continuous. Yeah. But for the other side, that's the first problem I have, because now you'll not collect a continuous data point. You'll collect a discrete data point that will convert to a continuous, in it to be a continuous form data point, quantitative. Then you have not told me the other side now. The other side, which is what will be the ordinal qualitative data point?
We shall have
performance in terms of what?
We shall gauge them, let's say, by the satisfaction of their constituent. Yeah, we shall have a form that will be duly filled by the citizens.
Okay, that is very, very good. Plus, you can say I won't collect discrete data point. I'll ask them which age group are you? Is it between 40 and 50? And then now I'll be collecting a continuous data point. So your answer is valid. Thank you very much. Thank you very much. Peter, have you thought of another example? Buiri has talked about salary given to employees with respect to job rank. Yeah, job rank is ordinal, but I was talking about continuous. Salary is not continuous. Is salary continuous, Kweli? Salary is not continuous. Salary is not continuous. I don't think salary is continuous. You can think about the data points first. Think about the data points first. I'll think of one as I go. Oh, Cynthia, the question was using we are not in that section of the class, so that's why I'm we are not in that section of the class. We were talking about quantitative data point and a qualitative data point, and we were talking about the different types of quantitative data points, which is discrete or continuous, and different types of qualitative data points, which is nominal and ordinal. So we are trying to create a research that uses a continuous quantitative data point and an ordinal qualitative data point. So I'll